Both. How are you doing?
Good. Waiting for the long weekend.
Oh yeah. In Vancouver also there's a holiday on Monday.
Yeah, I mean, Victoria is a federal holiday. Victoria Day.
Today is it?
Victoria is the federal holiday, right? On Monday?
Oh, I thought it's only on Ontario.
No. It's. I think it is related to the Queen or something.
I see.
So I think it's. I mean, I don't know. This might be weird for other guys, but what I've noticed is because it's Victoria Day, everything is closed. Even shops and uh, malls and everything, right? There are a lot of.
Oh, but people here is like I'm finding it very awkward. Like people here. So this guy who called me from TD Bank, he was
Yeah.
like from the bank, and he was setting up my bank account.
That's
Road sense, right? I actually like it here. So people are, wait till even like when like the pedestrian crosses the entire road, and so you have to wait. And because of this, right, when I came here, I had this bad habit, like bad Indian habit of, driving fast and all of that. I failed the driving license 3 times. 3 times. Okay. So just
I'm so
because of that
sorry.
bad Indian habit or bad Bangalore habit of, hustling around, I saw that okay, that the car is coming far away, and I just crossed this very far away, and then she just failed me. And then other time I did not, I saw that pedestrian is there, but I saw that like I can move fast and cross it by the time it reaches, like person reaches, and then she just applied the brakes and failed me. So yeah, and then I realized that I need to come out of. I need to
Yeah,
unlearn.
the
I need
driving
to unlearn.
sense, the driving sense is on a different level. I mean, if
Yeah.
somebody is on the pathway, just facing the road, then you people stop. Just thinking, and they'll ask, "Do you want to cross?" Then I'll take my car.
Yeah. Yeah. It's very awkward. I mean, it was awkward for me. Okay. But yeah, it was like, how should I say? It's like unlearning a lot of things. Okay.
Yes,
If I was like a kid, like for my son, he just figured out all the rules and everything quickly. For me, driving on the right hand side instead of a left hand side of the road, it just took so much of time. It is taking so much time to forget that the switch turns on when it's up. So it's just taking too much of time. For the kids, like for those who are learning first time, they do it very quickly. And that's the same thing with like this Python class, the course as well, right? Like if you yeah, I have a younger people, right, who are in like the BTech second year or BTech first year. They learn very quickly. Okay, they just learn very quickly, and then and the people of my age find it difficult. They take longer time. Okay,
that's such a
yeah,
ageist sentence.
huh?
I know.
Yeah,
That's
so
yeah.
it
You can't.
I observe myself. I sit with my son, and for the same problem, like we were learning a new language. He was learning this language called Lua. He was very quick, and it took me a long time to forget Python, forget other things to learn. So yeah, I mean, I'm not saying prejudice. It's just that the
I was just
learning
kidding.
styles are different. Okay, so I
Yeah.
think mm, we need to put an extra effort in forgetting things, make more memory space, and then do that. And yeah, unlearning is a double effort. Okay.
It's gonna be fun when kids normally learn that parents can't make them do things which they don't want to do, right? He or she will just come and tell you. If you tell them to do anything, they'll say, "You know what? You can't make us do. I don't want to do it." That's the first thing we say, Kilan. Trust me, I have
Mm,
my son here.
mm,
It's like We have to make them learn that though you are in Canada, you still have Indian parents.
Yeah, that's what we do. My
Yeah.
kids are born here.
But
I'm from California, but I say, you know what? We are Indians. You gotta listen to.
no, there is something that I like and I respect that part even in my class, and I'll connect everything together. So in India, the student respects the guru and the teacher, but the guru doesn't respect the teacher, the student. And I have learned in my last 10 years that I have to respect every of my students, every learner. And it has taken me a long time to learn that part and unlearn that part that that I had a huge respect for my gurus, but I never had that respect for my student. And it has taken me 10 years of practice to, bow down to my students and listen to their question. And the same thing which I find with the culture here, that the as a parent, um, we expect the respect from the kids, but we don't respect the kids' choices and their life. And so I think it has to be both ways. And I think in the same way, I think my learnings are good, and because of which what happens is when I hand over the class to somebody else, it becomes very difficult for them to manage because they are not very used to being questioned. And it has taken me long time. I can honestly tell you my struggles with this. And at first, the questions that people ask in my class look awkward, but when I listen to them 2 to 3 times, then I realize, oh, this is deep. Like in my other class as well, right? I mean, the who's of who of machine learning has attended my sessions. Okay, and so this guy who has a Linux book, very popular book on Amazon, he was attending my classes, and he came out very strong as like a very aggressive. That was my first, probably second batch or so. And then it took me a while to realize that I got to respect the question. So anyway, coming back to the class, yes. So we are talking about something most wonderful thing and most beautiful thing about programming, something very spiritual in nature, which is called recursion. And I consider it is spiritual because it has got a large history to it. There was a lambda calculus, then there was a church around the lambda algebra, and there was a lot of history. And then we have reached to the functions calling itself. Okay. And I'll talk about that more. So even though these ideas that you see today, Python having functions, calling functions, they might look very simple, but the history behind them is it's pretty complex. Okay. Like those who had been designing them for the first time, they had a hard time conceptualizing it. Okay. But thanks to the time, the how should I say, the science of first century becomes the common sense of the second century, and that's the scenario with the programming language. Now, did anybody try the 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 Tower of Hanoi?
Yes. I'll
Awesome.
ping you, Sandeep. I'll ping you.
Okay. Just share here.
Yeah, I'm sharing on the chat.
Okay. Veena, did you try?
Yeah, I tried, but it didn't went well. I'm still stuck.
Oh, show me. Yeah.
Okay.
Yeah. I want to see that struggle is something. Okay.
So I just ping on the chat. Maybe you can run this copy paste.
Okay.
See.
Okay. Ranveer, you got to be honest with me, okay? So question is, which part did you ask ChatGPT?
Some
I
sort of help.
recognize this code.
No. So some sort of help, definitely. Not ChatGPT, but
Okay.
Google and all, trying to find out, how we can do and all. So yeah, absolutely,
Okay.
nothing to be hide here.
Yeah.
But yes, trying to understand, how it can work, and then,
Yes,
what we
yes,
can
yes,
do.
yes.
So
Yes.
it's things will
Did
go
you
hand
get
in
the
hand.
feel? Did you get the feel of it that how it's working?
Yes.
Oh, awesome.
I continue keep changing the number, right? That's where you
I
can see
see.
the permutation combination, how it's
Exactly.
coming.
Exactly. Okay, Avina, feel free to share your screen and then we'll walk through. Okay. Or I'll just copy paste your code and all right. Great. Anybody else? Okay. Yeah. Anybody else? No. Did anybody try? No, didn't get enough time. You want to try over the week, but that's good. I would say that we will end the session with at least 4 to 5 problems that you can try over the week, and everybody should and must try recursion. This is the first non-common sense idea that you are receiving. So far, if-else conditions, variables, functions were all just common sense. Okay. The recursion is something that it just how should I say is a very interesting phenomena. Okay. And we will end I will create a new notebook today, 18th May. Yeah, 18th May, ML. Good. 18th May. And I'll just copy. This is Vina's one. And this is, okay, perfect. Okay, all right. Perfect. Now, so,
Sandeep, you are not sharing the screen if you are trying to.
sorry. Okay, thank you. Yeah. Let me close this older notebook. We have a newer notebook. I will be right here. There are a couple of things to do. Number one, we will end the session with at least 5 problems on recursion. Okay, or as in what else is there? So I've just changed the type of this cell into the markdown. Okay, and that's why it won't run. It'll just display nicely. Okay, so to do is we will end the session with 5 problems on recursion, and we'll spend good time on recursion. Okay, recursion is probably the most magical thing, and in case you guys are interested, Tower of Hanoi, and you can take a look at this cool not this one. There is a wonderful video by a YouTuber called not this one. It's called Reducible. Yes, here. Okay. This is probably the easiest way to visualize.
Honestly, if this doesn't blow your mind, do you even have a soul? The Towers of Hanoi problem is a classic recursive problem that can cause endless amounts of frustration. When I first encountered this problem, it took me several days to come up with a solution, and quite honestly, I didn't feel like I understood the solution
So yeah, I think you can do the homework, but what happened to my screen?
Our goal is to come up with a general strategy for solving this problem. If you're like me,
Okay. And we had the one good strategy yesterday, right? We solved it for 2, then for 3, for 4, like that, right? Okay. So one of the things that you need to do is you have to solve the problem for, let's say, 1, okay? And then how do you go from one to another, right? It's like to reach somewhere, like to climb somewhere, you got to use a ladder, the first step, and then from first step to second step, how do you go? That is what you need to figure out. Okay, so essentially, just like mathematical induction, the one that you had studied long back, similar to mathematical induction, recursion is also like that. That given n, right? Do it for n minus 1 and then, okay. Now here we have, where was it? Yeah. So we had move to, okay, move to and move 3. Okay. So move 2 and move 3 is clear to everyone, right? Move 2 is, so let's say we have two disks. How would you move them? Okay. What you will do is you will move 1 from source to auxiliary, then move 2 from source to target, and then move 1 from auxiliary to target, right? Now you can further make it like this. Let's say move 1, okay? If you have moving 1 from source to target and auxiliary, okay? So you can say move this, okay? It's pretty simple. And also we can just say move n so that we don't have to again and again keep changing this number, okay? So we are saying basically moving 1 disk from source to target using auxiliary is pretty simple. Just print move 1 from source to target. Perfect. So if you call this, okay, move 1, you say 1, move it from A to B using C. All it'll do is it'll basically print it. Correct? So that's all. That's all. And those who are getting annoyed with this, you can basically do it in a slightly different way. You can also make it a little better. Okay, there is something called a format string. If you say F, and you can basically just put the variable name inside the string like this, so that it automatically picks up the value from there, and you don't have to keep on concatenating the string, right? Because you are concatenating the variable into a string. Therefore, you have to keep on doing this back and forth, right? Therefore, what I would suggest is that we will use from source to target, okay, and this should be good enough. Okay, does it look okay? Yes, it looks so good now. So this is a neat way of basically instead of concatenating variables into a string and printing it, that becomes very annoying. So you can basically just put F in front of the string, which means format string. And then in the curly brackets, you can put the variables. You could also, okay, yeah. So you could also do a little bit different things. Python allows you to do this thing multiple ways. You can say percentage as here, percentage as here, and percentage as here. Okay, and then you can say, here are my variables, n, comma, src, comma, target, something like that. Okay, and moving n from source to target. So you can basically see that this is another way to do it. Okay, so I hope this is clear. And basically, as you will learn from this, you will see that there is a lot of small things that Python provides for making your life easy, right? So this is clear. We are moving one disk or nth disk. If you say move 10th disk from here to there, then it will do, right? Now, what to do when you want to move two disks? You basically say move one, okay, move, okay. Let's say here, we are assuming that there is n is going to be 2, okay. So we are going to say move the first one, which is n minus 1, okay, right? Or let me just make it a little more simpler. Let's say n is going to be equal to 2. So n minus 1 meaning move 1, the top one, from source. If you have two disks, what will you do? First, take the disk at the top, move it from top to the auxiliary, which means take it from source, move it to auxiliary, and we are just passing the third one like this. Okay. So we are saying move n minus 1 from source to target. Okay. And then what we are saying, then what we are saying, we are saying move 2 from source to target, correct? Now we can say, okay, move, okay, move what? Move
N from.
and move n, yes, move n, or let it be like this. We'll just talk about this later, okay? Now, once we have moved the second one to the target, what we have to do? We have to bring back the one that we had parked earlier. Okay, so what we're going to do? We are going to just bring back from there. Okay, now we are saying bring back from the auxiliary to target using source as the third line. Now let's take a look. Move to, is it working? Let's say my source is A, target is B, and auxiliary name is C. These are name of the variables, and these are the values we are giving them. Okay. And so here, first, top one is being moved from 1 to C, and so on. Now, the cool part is this. Okay, cool part is this, that if basically, how should I say? Right. So what we can do is we can say that, okay, first, whatever it is at the top, okay. So what we are trying to do is here, okay. So the trick is to realize that if you have n disks, okay, move n minus 1. So this is our source, this is our target, and this is our spare one, auxiliary. So using the third one, we have to move everything from here to here. Okay. So we can do this very simple trick that if you are given n number of disks, what would you do? You would move n minus 1 from here to auxiliary. So we will move n minus 1 from here to auxiliary. Okay. and then move the last one from here to the target. Now, then we will move. Now, these things are going to be here, and the third one has been moved here. So then what we'll do? We will take these two and say, okay, move these two, whatever you moved earlier, move them back to this one using this one as a spare. Is it clear? So we have solved the problem that in any case, very simply, okay, very simply, we are saying, very simply in plain English, we are saying, okay, to solve the, to move the n disks from A to B, right? And given C as auxiliary, what you need to do is first move n-1 disks from A to C, and then move the last one, okay, move the last one from move the last one from A to B, and then okay, and then move the okay, so this is my step number 1, this is my step number 2, and this is my step number 3, and then move back the disks from C to B, which were moved to C in step number 1. Okay, so we have converted the problem just like we converted the problem into n-1. Okay, so if you have 3 disks, so what will it do? It will first move 2 disks, right, from A to C, then move the third disk from A to B, and then move the 2 disks from C to B. Yeah, this is clear? Okay, so to move 3 disks, this is what's going to happen, right? Honestly speaking, it might look simple when I'm doing it, but I had taken very long time to solve it, maybe a couple of days, or maybe actually I had taken much more time than that. Okay, so okay, now we are saying, okay, now is it true for even 2 disks? To move 2 disks, can I repeat the same process? First, move one disks from the top, from A to C, and then move the second disk from A to B, and then move one from, okay, is this true?
Yes.
The second
Yeah.
step, which is there in the first one, we can move 3, we can maybe call it move third.
Yes. Move, yeah, move third. Yeah, we can say move third. Okay.
So confusion.
Yeah, this is okay.
Yeah.
Basically, this is printing. Okay, this is printing. Okay. This is the only step where the move is being made. Okay. Now, can I do the same thing for, let's say, to move one disk? To move one disk, can I do this? can I do this? Move 0 disks from this to this, move first disk from here to here, and move 0 disk. I can do this, right? And if n is 0, we don't have to print this. Okay, so this one, don't print anything. This one would print. Okay, this is the only way. I'll just change one line here. I'll say make.
Sandeep,
Yes.
hello. Yeah, I have one doubt. That first line, move two disk for 3 disk A to C, right? So it will change the, like if there are 3 disks, so 1, 2, 3. So it will move the orientation, right? Order.
But
So
no,
they,
we are not really moving. We are calling the same function. And when you call the same function, what it does, it basically goes and calls move 1, move 2, and like that. Okay. So it's not going to just move like this. Okay. The actual making move is being done by this line here, which is basically not doing nothing but printing.
okay.
Got it? So now you can differentiate between this. So first one, right, is actually, yeah. Okay, so let me see. Okay. Let me see if I can. Yeah, go ahead.
Sandeep, one quick question. So line 7, 8, 9 are the ones which are doing your the main calling functions, right? Now you can't it won't be universal solution for any n, right? This is true for 3, but it may not be true for 4 because you will have to check whether the bigger one is not going on smaller one, right? For example, if you want to do it for 4, how will you do that? You can't do the first 4.
Good question. Good question. So it is, let's take a look at this problem, right? So let's see. Will it go full screen? Okay, fine. It went full screen. Yeah. So let's take a look. Okay. Imagine that we moved these two from here to the final one. Okay. We moved them from here to here. Okay. And now we are left with this. We moved this to here. So now the orientation is that the last one is standing in the target. This is our source. This is our target. This is our spare one, auxiliary, extra space, right? So we moved the last one here. Okay. Now, unless and until you make a mistake here when you are moving. So again, we will come to this situation, correct? Now, again, we are saying the same theory. Move the top one. So our objective is moving 2 disks from auxiliary to target, correct? From here to here, we have to move. Yeah. Or you can say A, B, and C. So we have to move these 2 disks from C to B using this as a spare, right? So what we will do, as we learn, the top one, we will move it here back, and then we will move this to target, and we will move the one that we moved here back here, correct? So I think I can just draw it. Drawing it will be easier for me. Okay.
Yeah, my question was, will it work for 4? It will work for 3 with the 3 with.
Let's say we have 4 here. Okay. Okay. 4 here, right? And we have to move from here to here using this as auxiliary. Okay. So what we will do, we have learned how to move 3. Okay. How to move 3 neatly. No matter how you place these 3, you cannot put these 3 underneath this, right? No matter how you move them, all of them are smaller than us, correct? Smaller than this. So you will try to move this from source to target. Okay. Now we just showed that 3 works. So this should work. Isn't it? Because all of these disks are smaller than this one. No matter how you place them, you cannot, they will all be at the top. So once we have understood that the solution works for 3, then it will work for 4 as well. So what you will do is, is there a way to copy it? No, there's no way to copy it. Okay, let me just redraw it. Let's say you're moving these here, okay, using the previous technique by first moving 2 and then coming to 3. You have, let's say, moved these. Okay, let's say we moved these from here to there. Okay. Now we are in this scenario. Now, sorry. Not here. We're supposed to move it in auxiliary. Okay. We were supposed to move it in auxiliary. Okay. We were supposed to move the top 3 onto from the source to the auxiliary. Right? And now we move this here. Okay. And then we will use the same technique to move this from here to here. Okay.
Okay. Got it.
Got it?
Okay.
So
okay.
Yeah. These are very, very important doubts. Very important doubts.
So we are changing, next time we are changing source and destination, right?
Yes.
Oh.
We are shifting those source and destination. Okay. And yes. Okay. Let me see. Can I do better than this? I don't think I can do better than this. This one I can do better than this. So this code and this code both are correct. Okay. And okay. So let me see. So here, if there is only one disk, we are moving it from source to target, correct? So here you can see that this one, you have to convert it into a string. Otherwise, it will throw an error. Because if you say print one plus from, okay, it'll throw an error. You cannot append the string. That's why she has converted it into this number. Now I'm going to do this curly thing. This is actually pretty neat. I'm still getting used to it. Okay. And okay. And all right. Okay. So now, if there is only one disk, we are just moving it from source to destination. If there are 2, then what we are doing? We are moving the top one from source to auxiliary. The top one from source to auxiliary. No, you have to. Okay, let's say this one. If right, if this is the case, then you are just moving it from source to auxiliary. Okay, and then you are moving and do this reverse. First move. Okay. I think, let me just see, comment out this for a moment. Okay.
Sandeep, what I did is I counted the disk from from bottom. I counted it as 1, 1, 2, 3, like that. So I was literally confused. Now you are counting it from the top, right?
Yeah. So see, the problem is that if you move the top one, right, the recursion has to be the other way, because let's say we are going from first, what you're doing is first you are moving the top one, because we don't know whether we are going to move the top one from source to target or not. Okay. Instead, what you have to do is you have to do this. Okay. So that's the only mistake you're making. Rest is all good. Okay. Rest is all perfect. And that's it. Source to from auxiliary, because we parked them in auxiliary, and we are going to move them to the target. And using the source. Okay, so now source becomes the auxiliary for the next thing. Okay, so that's it. All right, so you can see it works for 1, perfect. It works for 2, perfect. Then it works for 3. Yeah, perfect. So that's all. Basically, these two statements needed to be swapped because you have to move the top n-1, okay, and then move the last one, and then, okay. You got the point. So no matter how you number them, basically top ones you have to, top n-1s, you have to take and put them somewhere recursively. Otherwise, because you don't know the top, like the first one that you're moving, you don't know. And the last one you can't move. Got it? All right. All right. Okay, perfect. Perfect. Is everybody okay with this? All right. Now, can we write another variant? Let me see. Okay. Let me see. If n is 0, don't move anything. Okay. All right. Else, do this. That's all. Okay. This should also work. No? Do you see how it is working? This has minimum duplication of code. This one still has 2 duplication because here there is a print statement here. Same statement is being repeated here. Okay. So this one still has some amount of duplication, but this one doesn't have, the one that I wrote just now doesn't have the duplication. Okay. You can see that clearly. Let's take a case of 1. Okay. When n is equal to 1, what will happen? It will first try to move 0. Okay. Try to move 0. And when n is 0, it will not do anything. And then it will print 1. Then again, it will try to move 0, which it will not do anything. And that's it. Which code do you like more? The one that you got from ChatGPT or mine? I think these guys will just do this. I'm just seeing the Gemini right now. Let's see how it does. Okay. Write code for Tower of Hanoi. Okay. It is so common that they will have, yeah. So they also have that repeated logic. You see, this sentence is repeated twice. Okay. So I like this code, though mine requires 1 extra calls, but still it has the minimum duplication. It has a minimum duplication of logic. Okay. And
Can you
further, I can also say n greater than 0, and that's it. Okay. And that's it. Can I make it further small? I don't think I can make it smaller than this. So how many lines of code it is? 4 lines of code. Okay. All right. usually, yeah. This one, which one is your code? Abhijit, is that yours?
Yeah, in chat,
Okay.
the first one. It is same as, but it is actually it is converting the array to another array target.
All right. So what we are trying to do is, yeah, and Tower of Hanoi, source to target, and auxiliary, and then it is basically print two from
That is
this.
not required.
Okay.
That
So Tower of Hanoi, basic. Okay. 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 Interesting. So you have given them the names, right? In the beginning, you have given them the names. And what you're doing is you are moving, wonderful. You're moving one, like all of the ones that are at the top, you're moving them from, from, so, okay, you basically, yes, perfect, very good. And then you removed the first one, right? You remove the first one, okay. No, pop means last one. This would remove the last one, correct? No.
actually it
Okay.
is 0. So
Yeah,
0 is the
zero. So
index.
it'll remove the first one. And then what you did was you inserted that into target. Okay, perfect. And then this. Okay, so you have actually moved these things that way. Perfect. Perfect. This is very good to if you're going to use the graphics tool to do the work. Okay, so you have actually physically moved things. You first of all you started with src equals 1 2 3 4, and then what you did was these things like these ones you pick them and put them in a right. You tried moving with these values, okay, and then once
Yeah.
you have moved them, then you appended whatever you just the last one you appended to the target, and then you moved back all of those, okay, but the auxiliary will contain everything, right? You don't have to leave out one. Why are you leaving out the one?
So so when Tower of Hanoi will be n minus 1 is in the auxiliary, at that time we need to move it to target. That is why it is here.
No, my question is this auxiliary, you are
Mhm.
only picking okay, we can remove this because this is redundant. Okay. We can remove this. This is redundant. Perfect. Let me just clean up the code. Okay. And so you are basically you took the target, put it there. Isn't it leaving it? Let me see. I think there is a bug in this. Okay. And okay, let me just separate out the piece of logic. Okay. All right. Good. Now here is a very important thing for everyone to notice. Okay. Here is very important thing for us to notice. Okay. And yeah. So okay. Wonderful. So if the length of SRC is greater than 0 or equal to 0, you are returning. Otherwise, you are right. You're doing nothing in that case. Otherwise, you're moving everything from here to here and this. So I see a bug in this. Let's take a look at, say, case of 2 disks. Okay.
Mhm.
And the target is okay. Okay. And let's see print auxiliary. Okay. Interesting. Interesting. So when you so you took the top one, moved from source to target. Okay. So what you will do is you'll remove the, let's take a case of only one. Okay. And target, like we will do this source. target and auxiliary. That's the thing that we are doing. Perfect. So in this case, very simple. If let's say we only have one element, what is happening here? You are basically printing this. Okay. You don't need to print it. You just are, yeah. You are actually moving things, right? So what you will do here is, in this case, if, right, it'll go here. It'll not do anything. Okay. What it'll do is it'll pick up this value from source and insert in the target. Perfect. And this one will not do anything. Now, let's say we have two elements. So what will it do? It'll first move the n-1, which is 2, from source to target. Perfect. And it will take the source to auxiliary, right? Source to auxiliary. Source to target using auxiliary. Let me just think. So what are you trying to do here?
It will move n-1 to up to n-1 to auxiliary. Then move whatever is the last position.
No, here we are saying move from source to target.
Yes.
Okay. Move from source to target.
So n-1 will be moved to target.
N-1 has been moved to target. Okay.
Yes.
And then you are, okay. How can you move it? Because let's say, that is my question. Since you're not printing it, you are not realizing the move. Okay. You have actually violated the principle, right? You actually just inserted it. So what happened was, let's say there are two disks, correct? Right? So what you did, you are moving this from source to target, correct?
Yeah.
So what did you do? You basically moved it from here to here, right? Okay. That's what you did here. Correct?
Yeah.
And then what you did was you picked this value from here and inserted before this one.
Okay.
Correct?
Yeah, seems like that. Yeah, I can try that. Yeah. Okay.
Yeah. So, but the most important part I liked about your approach is your approach is genuinely good, and it is actually a smart move, right? You're physically moving. If I have to correct it, what I'll do is I'll basically just follow the principle above. Okay. What I'll do is if length of src 0, do nothing. Otherwise, move everything from first element onwards, from source to auxiliary. Okay. Using from source to auxiliary, using source to auxiliary, using target as a extra variable. Okay. Source to auxiliary. Yes. Using target as extra pole. Now, what I'll do is here, I would essentially move, right? Because now I have, moved all the elements. So basically, I'm assuming that when it moves, it has also moved the last everything above. So I can just say pop, which means it'll just pull out the last element left. And then after it has popped the thing, as in the last element, what it'll do is I will say target dot append. Okay. Now append will only put it on the top, and pop will only take it out from the top. Okay. And that will basically make sure that, right, that it will basically, okay, like this. Okay. And now what will I do is, I will move back from whatever I moved from auxiliary, all the things that are in auxiliary to the target using the source. Okay, let's see if it works. And let's say I'm saying move 1, 2 from A, move 1, 2 to let's call it target equals empty, and auxiliary source. So we are saying, okay, but I like the approach very much. Okay, and this is a new approach that I'm seeing after a very long time. Okay, and yeah, and also here I can also do a bit of print saying, okay, okay, before this I'll just print, okay, print moving last element. Okay, last element, how will I take out? I'll say src -1. This gives us the last element. Okay, moving the last element from right to, okay, moving this from, okay, to target. Okay, this is hard. This is hard. I can't. How would I show that where we are moving from and where we are moving to? Okay, okay, to, let's say I'm just printing it here. Okay, just for the sake of okay, and yeah, perfect. Okay, it did not print these values. Okay, I did not put the F here. Okay, what it is saying? Yeah, okay. So moving to the empty, moving to empty. Okay, okay. So I think what we will do is we'll do a little bit different thing. We will define their names as tuples, okay, so that we can identify what's happening. Okay, yeah, so that we can display that. We'll just put a tuple, okay, so that we can display what's happening in there. Okay, all right, yeah, like that. So we can now say that src, like, okay, src, how do I pick src? Like this, and yeah, this way I can say moving this from src 0. Okay, all right, be with me. I know I'm making the things a little complex, but I think it is needed. Okay, what happened? Where did I make mistake? It says that there is some sort of a mistake. So I'm popping it from here. Oh yeah, here. Length of src and 1. Okay. Where did I make mistake? So what I did was I defined them like this. Okay. And here, okay, here is the mistake. Okay. Here is the mistake. Okay. This is a new tuple. Yeah. Okay, will it work? Yes. Okay. So what I did was I carried on with your way of style. Okay. Just that for each pole, there is a name and the content of it. Okay. The name and the content. So I gave the name to each pole and also have one variable to represent what is there in that one. Okay, and that's what I played around with. So here I said, okay, keep the name same, but just change the content of it. And that's it.
Okay.
All right. So this is good stuff, very good stuff. And yeah, perfect. I think
So line number 7 we may get out of that recursion error because we are not reducing the size of aux in that line
we
7.
don't need to. We are just moving whatever we moved to auxiliary, we're just moving back all of it here.
Can you add 3 in A? Yeah. Yeah, the third element in the A.
Yeah. So you are right. Here.
So it is.
Okay.
So aux we need to reduce.
Wait. But didn't we move from source to target using auxiliary? No. Here we made a mistake. Let me just. Now, where is my code? Yeah. Source. We are moving these many elements from source to auxiliary using target. So only those many elements are there, right?
So whenever we want to do n-1, we are doing it in the auxiliary, and that is how. So whatever source has, so n-1 will go first to auxiliary, and then
No,
from
there is.
auxiliary to target.
No. So see, look at it this way. Okay. So if you have, let's say, 2 elements, okay. If you have 2 elements, then what will happen? Or let's say there is 1 element, okay. In case of 1 element, what will happen? It'll basically not do anything here. It'll move that 1 element, and then it'll append it, and then move it back from auxiliary to target. Now, let's say there are 3 elements, okay? So, so here, first it moves the third one from A to B, then moves the third one from A to C, okay? That's weird. Okay.
I mean,
a mistake somewhere. May move 2 from A to C, move 2 from A to B. No, this is wrong. Move, let's say this is how they're numbered, right? This is how they are numbered. So we are saying this is 1, this is 2, correct? So we are saying move 2 from A, B, C, move 2 from here to C. Now move this 1 from A to B. Why it is saying that? Okay. I think there is a mistake that I'm making while printing the.
Earlier we numbered the
Yes.
other way, right?
Yeah. I'm just thinking, where is. So we are not really moving things from one place to another. It should be moving, right?
It is moving.
Yeah. Print. Okay. Nevertheless, but this is an interesting problem. You'll enjoy this solving many ways. Okay. The 1 element, it has moved from source, and then okay. Can I just print it everywhere? Okay. As soon as it finishes moving, or let's say as soon as it finishes moving, or starts moving, it just shows me this. Okay. Okay. All right. Yeah. So at the start, A contains 1, B contains nothing, and C contains this. Perfect. Now I'm saying A comma this. Okay. So at the start, A contains 1 comma 2, B contains this. Why is it? Shouldn't A contain only okay, A. No, I think I may made a mistake here. I'll think over it. I'll think over it. This is a very interesting problem. This is a very interesting problem. Probably.
No, but yeah, number 7 is the actual moving part, right? It is actual doing the pop and appending.
Yeah.
Correct? You
Yeah,
are not
this is
using
the one.
auxiliary. You're not using auxiliary there, right? So what is happening is
I'm assuming that this will be using that auxiliary internally. The problem here happening is at this point. Okay. So what's happening is I am saying that move these many from here to there. Okay. Now, when it calls recursively, what happens is that it doesn't really reduces the size of the problem. Okay. And that's what is happening. So let me think over it. What can be done? Because there's a mistake here. Okay. Probably, yeah, that's a good thing. I think you can give it a try more. You got the problem, Abhijit. But yeah,
Yeah.
I'll also work on it. But this is a good way. If you are tomorrow, let's say you want to move things really physically, okay. In that case, probably you have to implement a logic like this. Okay. Question is a solution from Vivek. Let me just go through it. Okay. All right. Okay. So move 1. Okay. If n is less than 0, return. Else print move from here. Okay. And that's about it. If n is less than 0, then return. Otherwise, move. Yeah. I think this one you don't need. Or you need. Does it work? Yeah, it is working. Awesome. Even if the thing that you had written, that is also perfectly fine. Awesome. This is also
Move
good.
one, Sandeep, in that move 1 from A to B, it should be A to C, right? First.
Which one?
This move and I'm just checking the output. It is saying the first one is not the code. You see the output. It should be
No, if you take 2, move A from 1 to C, move A to B and C to B, right?
Correct.
So, but when you do 3, if you do 3, what will happen? Okay. Move 3. So you moved the top one from A to B. Okay. So, okay, let me just draw it. Okay. Right. So let's say we had 1, right. Sorry. 3, 2, 1. Okay. And we are moving the top one from here to here, A to B. Okay. And this is removed. Okay. Then what did you do? Move 2 from A to C, 2 from A to C, A to C, 2 reached here, and I'm removing it from here. Then move 1 from B to C, 1 from B to C. Okay. I'm moving 1 from here to here. Okay. Moving 1 from B to C. Then I am moving 1 from B to C. Perfect. So far, so good. Now move 3 from A to B, move 3 from A to B, from 3, I'm moving from A to B. Delete this. Okay. And then move 1 from C to A, 1 from C to A. So 1 comes here, 3 is here, and C to A. Now next is move 1 from C to A, move 2 from C to B, move 2 from C to B. The 2 is moved from C to B. Okay. Then move 1 from A to B. Okay. Yeah. Cool.
Yeah, thank you.
Awesome. Any other? Okay. Yes. So as a assignment, I think try coding your own strategy and see if you can bring the size of this one down to, I mean, if you can write a smaller code than this. Okay. Okay. Yeah. All right. Okay. 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 All right. Does anybody has a problem in mind that do you want to solve?
Hey, hi, Sandeep, Pranita here.
Hi.
Hi. This week also I'm traveling, so I'm little inactive in sessions and doing hands-on. Spare me, next week onwards I'll be active. And coming to recursion, I don't know, for some reason from beginning of my career, I have some resistance towards this recursion. And whenever a problem is given in interviews or anywhere, I try to jump to iterations and solve it. They even question factorial or Fibonacci. Why don't you go for recursion? I straight away tell them, I somehow don't like it. But my passion towards recursion. Now I am planning to do this activity this week.
Yeah. Yeah.
And
So I think
parallelly, my brain is again curious. I want to try this out in iterative way as well, along just to see how it goes. Yeah.
Yeah.
So
Yeah. So I will
performance
show
wise,
you,
there are some
guys.
perks in iterative ways, right? So why do people still tend for
Because
recursion?
it's easier to solve a problem. Honestly, like I recently published a calcu chat. Okay.
Okay. Is it the number of lines of code that is smaller?
It's easier. You think of it. I can guarantee
Yes,
that
definitely.
try
I see now.
writing
I never.
Tower.
Yeah, Tower of Hanoi that is what made me understand. Yeah, recursion is very.
Yeah.
Yeah.
So Tower of Hanoi is way harder to code
Yes.
use. Okay.
Yes.
And it's so easy using the recursion. Okay.
Yes, this is the first problem that convinced me. Yeah, recursion makes our life easy.
I'll show you another problem. Okay.
Yeah, sure.
I'll show you another problem.
Yeah.
So if you go to github.com, Giri Sandeep, and here, and you see the, okay, where is the calcu chart? I keep writing the, yeah. Okay. So here is a very simple problem. Okay. And if I could share my screen in some way, I would love to do that. Okay. if I could just share the screen in some way, it'll be fun. I want you guys to think over how would you solve it. Okay, let me see if I can. Waiting for host to add. I'm the host, right? I can add. Oh, it is not showing me. Who is the host? Me is the host. No, not this one. Leave the meeting. I'm joining the other class. Okay. What is this? No, not this one. Okay. I'll show you some other day, but here I think you will see it very simply. Write your first Flutter app, online documentation, CalcuChat. Yeah, this one. So, oh, it has removed my app. Is there a way I can show it somewhere else? I think the best way to do it is using the Android app. I'll try to join the meeting right away. Be with me for a moment, and I think I'll be able to show you what does it mean. Okay, so here it is a very important example. Okay, so I think for everyone, this is another something that you should think about, like how would you deal with it. Okay, meetings, join, and what is the meeting ID? Meeting ID is 818-127, 818-127, 818-127, 767, and no. 818-127, 767, 74. Okay. Passcode is 436. Passcode is 436 382 382. Okay. Okay. All right. So I've not joined it. So there must be a way to share the screen, right? Let me share my screen. All right. Yeah. So for some reason, the Google has taken this offline. Okay. There must be save. Okay, Google Drive document screen. Start now. Okay. You guys can see my screen? No.
No.
Yeah.
Allow. Okay. Just give me. Oh man, don't tell me I have to restart the Zoom meeting after all of this. It's asking for permission. Okay. All right. Okay. You can see my phone.
Yes,
Yeah.
we can see.
Yes.
So yeah, so this is an app which basically I wrote so that people can write, do the calculation. Say, for example, I am saying x is equal to 3 plus 5 times 6 minus bracket 8 to the power 8. Okay, so it basically has assigned that value to x and I can print it. So it has done that. So I can say x into x. Okay. and it basically does it. So think of it like, how would you create a program that takes the text string containing an expression and it evaluates the value of it. Okay, it goes character by character, understanding what's there, and then does the calculation. Okay, so everybody got this calculator, right? Like, got the idea of the calculator, what calculator is doing. So you can create complex expressions and the variable and assignments, and then do the calculation. Right?
Yes, Sandeep. Then what is the use of recursion here?
Yes. What's the use of recursion here? Okay. When you will code it, right? So there are multiple ways of coding it. Okay. And the way you do it with recursion, it becomes super simple. Okay. I'll just show you the code and you'll get an idea. Okay. You'll get an idea. Yeah. I hope, but you understood the problem statement, right?
Yeah.
Okay. So now let me go back to the code. Where was my code? I think code was here. Okay. Code was here. Now, in this code, if you go to here, library, and there was a calculator service, I think this is the one. No. Yeah. So it's basically solving it character by character. Okay. So here, this is the main function. Okay. This function is making a call to addition subtraction. Addition subtraction is making a call to multiply divide. Multiply divide is making a call to exponent, which is power. Okay. Power is right. And let me go ahead. Let me go ahead here. The power is making a call to if you see, it's checking if there is a bracket somewhere. Okay. Let me show you. Yeah, here. Okay. Yes, it's making a call to atom, and then atom is making a call to addition subtraction back. Okay. You see? So this is a recursion of multiple levels. Okay. When you are creating a programming language, you basically write this recursion. Okay. You basically express it very simply. You'll say that, okay, one expression is expression 2 plus expression 3. Okay. Plus minus, right? Like that. So you can have like multiple such expressions. Okay. So that's how you defined it. Okay. Then you say, okay, right. This is the grammar you are defining. Okay. We are defining a grammar saying that to understand expression 1, you first take this expression. So one expression is optionally, these parts are optional. Okay. Expression 1 is expression 2 plus minus expression 2 and so on. What is expression 2? Expression 2 could be multiplication of some other expressions. Expression 3 are equal to expression 4 to the power expression 4. Then you are saying expression 4 is equal to the bracket in expression 1.
Okay.
You see the recursion?
Yeah.
Okay. So basically what you're doing is you are first going there, calculating, coming back. Okay. And this is the piece of code that took me a fair amount of time to understand. Okay, so when you are creating a programming language, a compiler, you always use grammar. And to handle the grammar, you write the code in recursion. Okay, that's why the thing that you see, I'll just show you. Um, book. Okay, and
Yes,
yeah,
sorry, just a silly question. Sorry if the doubt sounds too. So why only that sequence? Why plus minus then asterisk
yeah,
and then
yeah,
power? Is it
yeah.
mathematical rules that we are following here? That's why.
Yes.
Okay, okay,
Yes. Basically, we are following the mathematical rules
okay.
that
That's why.
first calculate the brackets.
Haha. But
Okay.
most.
Then come back to the power. Then come back to the multiplication. Then come back to the addition subtraction.
Okay, got it. Yeah, thank you.
Okay. So the way we teach our kids that, okay, first, if you
Mhm.
see, let's say 2 multiplied by 3
Mhm.
plus 4 multiplied by 5, first go and calculate this.
Yes,
Okay.
got it.
And you let's say here is
Power. Mhm.
power. Okay. And let's say power is having a bracket.
Yeah,
Okay.
but must. Yeah, thanks.
Yes. So what you'll do here, it's like here it will first go and think of right. So what will happen? This becomes expression 2. This again is another expression 2. So expression 2 is a function that handles this expression.
Mhm.
Okay. And then inside expression 2, expression 3 consumes 2, and this is again expression 3. Again, expression 3 consumes 3, and expression 4. Expression 4 is the bracket of this one, and so on. Okay, so I think when you do a bit of I would honestly suggest that you go through this particular piece of code, and yeah.
Yes.
And I also want those who are interested, those who got the hang of it, I would honestly suggest everyone to, you know, honestly suggest everyone to go through this one. I know that this is a bit too early for those people who are looking at recursion uh, for the first time. This is strongly recommended for those who are all comfortable with the programming and recursion already. Okay, so this is only for those who are already comfortable with the recursion. I want you to take a look at this one, and I'll give you one more thing. Okay, as a part of my class, I have to make sure that because some of the learners are way ahead and some of the learners are beginning, and therefore I want to make sure that it's the class is equally hard for everyone. Okay, and yeah, so how can I make it look like a code? Yeah. Okay, so this is one thing that you can take a look. And the second thing, I want you guys to take a look at this particular book, those who are interested. It's one of the most beautiful books I have found. Okay, uh, and it's specifically for recursion. And um, where is my functions? I someday would write a book like this for Python and machine learning. This is okay. That's something that let me see. Oh, it's not really.
You change the page number in the top 73 direct. And that page count.
Okay. So in this book, which is that 70?
73.
It's actually somewhere else. Okay. This is one of the best books I read on an NC. it actually, I mean, this is where my inspiration comes from, because I realized that while teaching C, this book taught me data structures, algorithms, and so many other things, right? The way a dictionary is implemented, I learned while reading this book. Okay. The way internally the dictionary is implemented in Python, I learned as part of this book. While I was learning, okay, that we are supposed to learn C. And like binary search is another binary search, the algorithm is something that I learned here. It was just involuntary and nothing. Okay, this is where my inspiration comes from. That in this class also, I'm going to deep dive into data structure algorithms in the same style as Kanigan and Richie. These guys wrote C programming language. Okay, they wrote C programming language. They wrote Unix, the one that you use. Okay, so these guys are somebody who actually established most of the internet, most of the computing as of today. So yeah, now I'll just show you that piece of code if I can find it. Okay, just give me a moment. I think I'll just pick from downloads. Okay, yeah, I think it should work better. Will I be able to find it? Nah, just impossible, I think. Okay, DDCL. Okay. Nah, it did not find it because for whatever reason, it's not, it's basically badly scanned. Okay. Where is my stuff? Recursion. Okay. And yes, pointers arrays. Those who want to take a challenge, I would just give you the snapshot of the problem, and then we will move on with the class. I think I should be able to find that location. Yes, I found it, finally. Okay, so yes, there we are. Okay, so you have to write a program when you give it, say, this kind of input. Okay, char star star argv, it should say that argv is a pointer to character. When you say this, it should convert it into plain English. Okay, similarly, when you say this, it should convert it into plain English, right? And when you go for really complex declaration, it should tell it in plain English. So essentially, given the piece of code, it has to convert that into plain English. Okay, that is the problem statement. Given a declaration, a complex dictionary in a piece of code, you have to convert that into plain English. Okay, think about it. How would you do it? Okay.
What about input? Input, what is the array number?
This is the expression. This is a code, C code. The input text is the code, C code, C programming language code, and it has your code needs to interpret it. Your code need to convert that into plain English.
For this, we'll also need to first have a complete list of all keywords in C and everything, right?
Yeah.
That has to be refreshed first.
So, but it's only for the declaration. It's only for the declaration and not for the entire code. It's basically the declaration, like this, not like entire for loop and everything. Okay.
Okay.
So yeah, that's the problem statement. Okay. And those who are interested in this, Okay. I'll just put a snapshot here, and then you can try finding it in the book. Okay. And yeah, where is the thing gone? Okay. Now, I just want to, those who are really interested in giving it a shot, I would recommend them to try this. Okay, so I put a screenshot here. So you can find the book, you can find this particular location, and then you will be amazed at this code. Okay, you'll be amazed at this code. This code is like, this is how it is showing the recursion, how it's handling. So there are two functions, DCL and dir DCL. They call each other. Okay, they just call each other and they solve it. So this is the only code. Okay, this function and this function is the only code that does all of this. And of course, reading the text, and that is this is the other code. Okay, so when you are solving these kind of hard problems, you need recursion. Like, there could be another question that write a wild card character matcher. Okay, meaning like if somebody says A star, it should match with ABC, A, like that. Okay, AB, AX, as well as A. And if somebody says A dot, it should match only with one letter or one character. And if somebody says plus, it should like only this, let's say, for time being. Okay, dot and asterisk, or let's say question mark. I'll just make it simpler. So why you must have seen in the DOS that you can do this. Okay, now if somebody says A star B, it should match with A XYZ B, A123B, as well as AB. Okay. And if somebody says A star B star C, it should match with ABC, A, B, 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 C, and so on. It should match A1, B1, C. Okay. So try writing a function called isMatch. It takes the wild, right? It takes the pattern and it takes this text to match and returns true or false. Okay, that's all. Okay, so that's the idea. Okay, that's the idea. I would want everybody to give it a shot, think about it. How would you build it? Okay, we will again come back to this particular thing later. Okay, now this is for those who are already through with you know, who are already through with the those who already through with the programming and are comfortable. These are the hard challenges for them. Okay, right. Go through these 3-4 things. Okay, I'm going to move on for more exercises, and but consider I request everybody that consider this class as a place to you know, where you work with me. Don't only consider it like a place where you just listen. You participate with me over the week. Work on at least 2 to 3 problems and fight. I mean, fight as in, the more you exercise, the better you get. Okay, and it's actually very simple. It's actually very simple. The more you exercise, whether physical exercise, it builds your muscle. The more you will try to code, the more times you fail, the better you will get. But don't give up. That is my request. Okay. Yes, Subodh.
Yeah, so for this, the last question,
Yeah.
if you go down. Yeah, for this, we want to just, I mean, can it be any pattern in the sense,
Meaning you mean to say
okay,
that, yeah, it can be something like this. Okay. Okay. So basically, right, the here the rules are asterisk matches 0 or more any letters. Okay. More characters. I'll just say characters. Okay. Characters. And question mark matches only one character. That is
yeah,
the
can you add one more test case as AA question mark B star or AA
question
star?
mark B star. Okay, so this would match
Yeah,
like here I'll just say
yeah, okay.
this would match AA B
BBC.
sorry AA B.
Anything.
It will also match AA X B
See.
Y. Okay,
Anything.
and so on.
0 or more characters. Okay.
Okay, so asterisk matches 0 or more. Okay,
Hmm.
and the first one it'll be AA. Let's say 1 B C D E F G H I J K. It'll match. So you have to write a function. You have to create a function which takes a pattern and the text, and it should return true if it matches the pattern. Otherwise, return false. Okay. Okay. Does anybody want to right? It should not match with AAB. It is not matching with AAB. It is not matching with AB. Okay, and so on. I hope you got the idea. All right. Perfect. Perfect. Moving on. A point from Ria is that sharing an approach I find easiest for recursion. Yes. First is find out the simplest case. Correct. And then assume your function solves the given problem. Correct. In our case, tower of Hanoi n moves n disks from source to target. Correct. Yes. Find out just one smaller problem. Just one smaller problem. In our case is this. And move n-1 disks from source to destination. And then write recursion relationship using step 3. Yes, that's exactly what it is. And this might look very easy, but this is fairly hard. Okay. The only way to achieve this is practice, practice, practice. Okay. Now, who will suggest some problems for recursion? Let's say. Okay. Okay. Yeah, go ahead. Who will suggest?
Sudoku, solving Sudoku.
Okay, solving Sudoku. I'll give this problem later because right now we have not gone through the loops. Okay, so I will go through the loops, then I will solve it. Okay, and I think solving Sudoku is a good problem, and solving tic-tac-toe.
We had one question. You have given one question earlier, that permutation thing. That
Yes,
was
yes, yes. Okay. Write all permutations. Okay. Print all permutations of a given list of characters, list of unique characters. Okay. And yeah. So this is one. Now, okay.
Hi Sandeep,
Yes.
am I audible? So I've dropped a question in the chat, right?
Mm-hmm.
If you go through it, it is an input of all the alphabets, and output will show like the count of the alphabet after the the continuous, and will leave the alphanumeric characters.
Okay, let's see what's exactly the problem. Here, we have what we have. We have input A, dollar, dollar, and then CC, and then dollar, dollar, and so on. Now, this basically adds 3 here, 2 here, and 4 here, and then 1 here. Perfect. So the moment it reaches non-alphabetic character, it just adds the number of characters, correct? Okay, that's the problem statement. Yeah.
And in the last, like there is no alphanumeric character, but it's still as the word change, it will
Yeah,
show the numbers.
yeah. So in the last case, basically what you, okay. Here, so as soon as the alphabetic character changes, you want to append the count. Yeah, perfect. Perfect. We will do this. We will do this. All right. I think it's a better thing that let me just go through loops and iterations, and then we will come back. I think I just realized that loops and iterations we will finish, and then come back to these problems with respect to the the uh, the problems programming problems. Okay. Now moving on. Yeah. So one of the most important things in programming is how to make things go in circles, right? Repeating things. And there are two kind of loops. One is a while loop, other is a for loop. Okay? These are mainly the two loops that are there in Python. First one is a while loop. Here you can see. So let's say we have n equals to 5. While n is greater than 0, print n, and then we are subtracting 1 from n. Okay, we are saying n is equal to n minus 1. In the beginning, 5, n is 5, so 5 is greater than 0. This condition is true. So it goes on to print 5. And then n is reduced by 1 because n minus 1 is 4, so n becomes 4. Now again, from here, it comes back again. From here, it comes back again to the beginning, right? Here it checks is 4, first it's 5, so 5 is greater than 0, that was true. Now n has become 4, so 4 is greater than 0. It again is true. Then it comes back and prints 4. Then n becomes 3. Then it comes back here, checking is 3 greater than 0? Yes. Then again it prints this. Then n becomes 2. Again 2 is greater than 0. It prints, and then again n becomes 1. Then it is still true, and then it prints 1. And once n becomes 0, 0 is not greater than 0, so it quits. And then it prints blast off, and then it prints the final value of n. So you can see first it prints 5, 4, 3, 2, 1, and blast off, and then 0. Is everybody clear? What does while loop do? While loop is basically, it keeps running everything that is inside while loop block. And how does it identify the block? Based on this tab. Okay, based on this tab, it basically identifies this tab that you see. Okay, this indentation is what identifies that what is there inside the while block. So the syntax is while followed by a condition, followed by a colon, and then the statements. All right. So I hope everybody is clear about it. We can just experiment with some of the simple problems. Okay. So when we want to keep, repeating something, we will do this. Okay. So let's say we want to, okay, give me a good problem. So let's say we want to, we want to go from n, like we want to, okay, print all even numbers. Okay, we are going to print all even numbers up to from 1 till 100. Okay, so we say n is equal to 1, and we are saying while n is less than or equal to 100. So notice that less than and equal to is like this. Okay, so we are saying while n is less than equal to 100, and we are further checking if n %2 equals 0, meaning n modulo 2, which means is the remainder 0? So this one computes the remainder. N equals n %2 means remainder. When you divide n by 2, what's the remainder? If it's an odd number, it's going to be 1. If it's an even number, it's going to be 0. So if it's a remainder, we are just printing n. Okay. And then we are increasing n by 1. Okay. So you can see it is started n was 1. It went here and it kept on, it checked. Okay. You can actually just print checking, and so you can see it's first checking 1, but it did not print. Why? Because the condition was not true. Okay. Then it was checking 2, then printed 2 because 2 is even. Then it kept on going up till 100. Okay. Is everybody okay? All right. Are you guys comfortable with while loop? If I forget to, let's say I forgot to increase this number, what will happen? I forgot to increase the number.
Infinite. It will keep running.
Yes.
Endless.
Will
N will
keep
remain 1 and keep going.
N will remain 1 and it'll keep on checking again and again, and it will give me an error. Right? You can see a
Stack
string.
overflow, maybe.
This one doesn't give an overflow. It just keeps it infinite loop. So you have to do kernel in
Okay.
There is no defense that they have built to stop it. Okay. That's why people do not prefer while loops. Okay. I personally do not prefer while loop. If I can do something else other than while loop, I would do that. Otherwise, this will basically keep running. There is no stopping to it. Okay. You see, it is not stopping. It's not going to Stack Overflow. There's no way that program can detect that there is an infinite loop, because computer is supposed to do what we are asking it to do. And if they are saying, okay, it has been running for so long, let me interrupt it and stop it, that is something that we have to do it externally, not like from the compiler point of view. Okay. So it is still running, so we have to do kernel interrupt. Okay. Now we stop the kernel, and that's about it. Now, so what we saw was that in case we make a mistake and the loop keeps on going, it's going to be messy. Okay, it's going to be messy. Therefore, people prefer the people prefer the for loop. Okay. All right. Now, I'll just take one more example. Okay. Let's say there is an array. I have 1, 2, 3, 4, 5. Okay. I want to create a new array with double the numbers. I want to, right? I want to multiply all numbers by 2. Okay. I want to multiply all numbers by 2. Okay. So what will I do? Okay. I will say my result is empty in the beginning. Okay. I'll say while, and I'll start it I equal to 0. So I'll say while I is lesser than the length of array. Okay. I would first, let me just show you what happens when I do this. Okay. And of course, don't forget to change y. Okay. I can say I equals to I plus 1, or I can simply say I plus equal to 1. These two statements are same. Okay. These two things are identical. Okay. I equal to I plus 1 is same as I plus equal to 1. Okay. Now see here.
Sandeep, we are not doubling the number here. So.
Yeah, we are not doubling right now. I'm just printing it. So that means our logic is correct, that okay, we are going from first element to till the last. If this was 20, this was 30, this was 40, we are able to print that. So we started, I was 0. Yes, go ahead. Not clear? Okay. So what we are trying to do here is that I is 0. We are saying I less than length. So it comes here, checks what's the length of array. Length of array is 4. Then we print the number, increase I, go back here. Now I is 1. Is it less than length of array? Yes. How much is length of array? 4. And I is right now, I started with 0. So we printed the 0th element. Then I became 1. We printed the first element. 0th element is 10. First element is 20. And then we printed 30. We printed 40. And at the 40, how much I became? I became 4. 4 is less than 4? No. That's why it broke. Okay. It said that, okay, we can't continue because 4 does not exist, because this is 0, this is 1, this is 2, and this is 3. Okay. So I hope this particular block is okay. All right. So right now I'm just going to, all right, I'm just going to duplicate it, and here I'll just change the problem statement, print all numbers from array. Okay. So here, now I want to duplicate, I want to write a function. Now I want to write a function. Okay. Let's call it double the value. Okay. Double array. Okay. And it takes an array as argument. Okay. It takes an array as argument, and I'm putting colon here. So I just converted this into a function. I'll put an indentation. So this became a function. Now I can use it like a normal function, double array. Right now it does not do anything. Okay. We will test it out in a moment. Okay. So it doesn't do anything. It just prints it. So what we want to do is, when we pass the array to it, we want to double every element and put it into another array. Okay. So let's say here, this is my result. Okay. So what we are doing, we are going over this array. And instead of printing, what we are going to do, we are going to say result dot append. And what is the value? Value is equal to array I, and we are saying value multiplied by 2. So let's go through it line by line. So this is my function, which is taking an argument called ARR, right? And this is my variable that's my input that I got in this variable. I'm defining a empty array for my output. Why? Because I want to return the double of all the values. So I'll return it in the form of array. I'll return it in the form of array. Okay. Now, initially my I is 0. So I'm saying keep doing this until I is less than length of array. Then I'm saying, okay, for I, let's pick the ith element from the array, put it in a new variable called val, and then in the result list, I am appending val multiplied by 2, and then increasing the index, and it goes back here, and then it keeps on looping through. Let's just check, is it working? No, because we forgot to return the result. Okay, so now it seems to work.
So Sandeep, append is important to use with result, or we can assign the value direct to result also?
Yeah, if we are assigning the value, what will happen? It will overwrite it. Okay, because we want to append all the values together and then give it return the result. If you assign it, each value will overwrite the previous values.
So 10 to 20 and then 20 to 40, it will keep overwriting. That's what you're saying. Okay.
Yes. So we are just appending the value to the array. First it'll append, right? You can just print on every time. You can say, just to take a look what is happening. So first, the value of array is 20, then became 20, 40, and so on. Okay.
We can write result of I equal to, that also will work, right?
Result of I.
I mean, result, and inside the square brackets, we can give I.
Here itself?
Instead of dot append, I'm giving result and square bracket I.
No, I mean result. Right now, result is empty. It will give an error if that particular thing is not.
No, we are assigning that value in val into 2 can't be assigned to result of I.
Right now, the result is empty array. So if you try to access it, it will throw an error that there is no position.
Okay.
So in an empty array, you will basically keep on appending, because if you try to access any element or try to write at certain position, it might throw an error. Okay. Is this clear to everyone? No? Okay. Are you guys okay, everyone?
Yes, Sandeep.
All right. Here is a question to all. Number 1. Okay, I'm going to give very simple one. Given 2 vectors, or you call it arrays, okay, return the difference of the 2 vectors. Okay. That is
Sandeep, is array mutable or non-mutable?
Array is mutable.
So, I mean, in your above code, do we need to take an extra array, empty array to begin with, or we can?
Good question. Good question. Very
we
good
can
question.
Directly amend it, right?
Good question. So question is that here we are unnecessarily wasting a space. We could basically just change the value in place. Like for example, we could just say here, instead of appending, we could say array I star into, okay, that's all, right? So this could very well work, and you don't need to do anything. You could just return the same thing. Okay, now what happened here? Yeah, so it is working fine. Yeah, it is completely okay. But as a good habit, we should avoid cutting the same branch on which we are standing, and that's why I'm avoiding that. Okay. And like like for example, I want to give some more exercises. Okay. Now, first, one exercise I want to give before we take a break. Given two vectors, or we call them arrays. Arrays are vectors in maths, and in computer science we call them arrays. Okay, list of numbers. Okay, given two list of numbers. Okay, or list of numbers. Okay, return the difference of the two list of numbers. Okay, for example, example input. Let's say, and let's call them, your function name is diff. Okay, so diff 1, 2, 3 and 2, 3, 4, it should give another list. It should print another list, okay, which should be -1, -1, -1. Okay, right? This is one question, right? Now, question 2, okay, given two vectors, given two vectors, right? Find absolute distance between them. Okay, what does it mean? Okay, what does it mean? What if, let's say, okay, we also call this distance as L1 distance. L1 distance. Okay, I'm going to show you. So basically, we'll say absolute distance. That is the function I'm expecting from you. Okay, if you say 1, 1, this, it should, and say 2, 3, 4, it should give the answer as, it should return the answer as, what should it be return? 3. It should return 3 as the answer. Okay. And if, let's say, this is 4, this is 4, and this is 5. So what should be the answer? Okay, let's say this is the input. So 5 minus 2 is 3, plus 4 minus 1 is 1, plus 1 minus 4 is 3. So the answer is 7. Okay, so it should give the absolute distance of the two vectors. Okay, is everybody okay with this problem statement? Please ask the question now. You can use the while loop. No need of recursion. Okay. Now, all right. Now, the third problem is on the same line. Given two vectors or list of numbers, find the mean. Find the mean squared distance, or find the squared, find the, okay, given, okay, given two 3D vectors, okay, 3D vectors, find the distance, okay, find 3D vectors representing 2 points, okay, I'll just say 2 points, and this will be tuple this time. Okay, this will be tuple, or let it be list. Let it be list. Okay, let it be list. We'll talk about tuple later. Find the distance between these 2 points. Okay. How do you calculate the distance between 2 points? Right. The way you calculate the distance between the 2 points is by using the Pythagoras theorem. Okay, Pythagoras theorem, and okay. So, all right. Or let's say start with 2D vector first now. Okay. So if you have right, how do you calculate that? Let's say you have one data point called 1, 2, other data point called 3, 5. The distance between them is how much? It's basically using Pythagoras theorem. We can find this this length, and then right. If this is x, this is y, how much is this? X square plus y square, square root, right? Am I making sense?
Yes, Sandeep, for the first question, the diff one,
Yeah.
both the vector length should be same, like the array limits, it could be.
Yes. You should throw an error if the length is not same. Okay.
Okay.
You should just return -1 or 0 or none.
Okay.
Just return none. Okay. And print that error. Okay. So given 2 vectors, 1, 2, this is one vector and this is another. Okay. We are trying to compute the distance. And how do you calculate this value and this value? By subtracting their x coordinates and y coordinates. Okay. So this can be calculated because this height is 2, this height is 5. So this is how much? 3. This distance from here, it's 1, and this is 3. So 3 minus 1, 2. So this is 2. X is equal to 2. And so 2 square plus 3 square is 4 plus 9, which is equal to square root of 4 plus 9, which is equal to 13. Yeah, square root of 13. Okay. So compute the square root of 13. And the way you calculate the square root is basically by using the math.square root. Okay. So when you call the distance, okay, 1, 2, and what was the second point? 3, 5, it should give how much is the value that's coming out to be? Math, which should be same as say square root of 13. Okay. Essentially, how much is square root of 13? You can just say import math.sqrt 13. Okay. So this value. Are you guys okay with the 3 problems? Will you be able to do it? That doesn't look good. Not interesting enough.
We'll try.
13.
Try it out.
We'll try for next.
Huh?
Yes, the how it come 13. This square root, that is 1, 2, 3, 5. Can you explain that part?
Yeah. So it'll be right. So first of all, we will calculate the difference between the two. So it'll be 1 minus 3 square, okay, square plus 2 minus 5 square, okay, 1 minus 3 square and 2 minus 5 square. Or you can just say, 3 minus 1, it doesn't make a difference, okay? Whichever point you pick first doesn't make a difference, okay? So you basically find the distance between the two, okay? So you use the Pythagoras theorem, you find the y difference and x difference, you found the triangle's length and the base and the perpendicular, and then you can find the hypotenuse, okay? By using the square root. Okay. All right. Simple.
Yeah.
Okay. Now, once you're done with it, then you say, right, given, okay, create a function called distance 3D. Okay. 3D. Okay. 3D. And figure out the formula. Okay. So using the Pythagoras, figure out the formula. Don't memorize the formula, derive the formula. Okay. I want everybody to go back to the basics and think about the Pythagoras theorem that you studied long back. And I want you to get back to that maths. Okay. So yeah, because I want to connect all the three dots, the machine learning, maths, and coding at a single place. Okay, that's why work with me on these problems, and we will go into more and more details about the things. Even if you are very new to programming, these 4 problems you should try to do. Okay.
Sandeep, can you copy and paste it in the chat?
These 4 problems?
Yeah, 4 problems.
Okay.
And
Yes.
Sandeep, just one thing which I'm curious to understand. In question 2, you are just calculating a difference, right? 5 minus 2, 3, 4 minus 3, 1. Then 1 minus 4 would be minus, or you taking 4 minus 1?
We take the absolute distance. Okay. This is called the Manhattan distance or absolute distance, right? This L1, this one, right? It's absolute. Okay. Imagine that you are on a grid. Okay. Let's say you are in Manhattan where the roads are completely like a grid. Okay. You are here and you have to go here. You are at a point A and you have to go to B. So you will have to take this way, this way, this way. So all these ways will have the same amount of distance. This distance is how much? 1, 2, 3, 4, right? And this distance is how much? 1, 2, 3, 4. This distance is how much? 1, 2, 3, 4. And how do you calculate? All you do is take the delta, compute the absolute difference, and sum it up. Okay, this is called L1 distance. This is called, the second one is called L2 distance. Okay, and that's the distance between the points. Is everybody okay with this much maths? No?
And the
Yeah.
4th one, can you explain again?
4th one, okay. 4th one is essentially, let's say you have a 3D vector. Okay, you have, let's say, a 3D vector. Okay, in 3D you have 1 point and second point. So the problem statement would be that if I ask you 1, 2, 3, okay, and I want to compute, here the problem is 2, 3, 4, okay, these are the 2 data points. Okay, so what you will do is you will calculate the distance between these 2 points, and first you will basically think of 2D only. Okay, just think of 2D only, and you will calculate the distance between their shadows, and then you will calculate. So the formula that will come out to be, it'll be x2 minus x1, okay, x2 minus x1 square. This is how you write a square in Python, double asterisk, okay, and y2 minus y1 square, okay. But I would still want you guys to derive it. Okay, I don't want you to assume it. You know the Pythagoras theorem. Using the Pythagoras theorem, find out the distance in 2D, find out the distance in 3D. Okay, I'm going to delete it. So this is going to be math.sqrt of 1, 2, 3. Yeah, this much. Okay. All right. Everybody got the hang of it, right? If you are in 3D, you are represented with 3 coordinates like X coordinate, Y coordinate, and Z coordinate. And what you need to do is find the distance between the 2 points. Okay. All right. For L1 distance, there could be any dimensions. Okay. There could be any dimensions. For 2D vector, there is only 2 dimensions. Okay. And later you can generalize it for, okay, right? Generalize problem Q4 for n dimensions. Okay. Meaning instead of 3 values in this list, it'll be n numbers. Okay. So these 5 problems are pretty simple, very simple. Okay. It's just that the interpretation of these is a bit harder. We will talk about interpretation also later, but for now you can just code them. First one is given 2 vectors, find a difference between each value and return the difference. That is the first problem. Second problem is find the absolute distance, meaning subtract each 2 values, take the absolute value. If it is negative, turn it into positive, otherwise let it be positive, and then make a total of this, meaning whatever you did in the previous problem, convert all the numbers into positive and then sum them up. And then the next one is given 2D vectors, find the distance between the two. Okay. Then given 3D vectors, find the distance between the 2 vectors. And then if you have n dimensions, okay, n dimension, like the 2 lists, find the distance between those 2 points. Okay. I hope you got the problem, everyone. No?
Yep, got it.
Everyone?
We'll give a try.
Yeah. Give it a try. Using the while loop, you can do code all of these. Okay. This one, Q3, Q4 doesn't even need a loop, but it's up to you. Okay. If you are writing the question number 5 first, solving the question number 5, then you don't need to solve question number 2 and 3 because they are special cases of the question number 5. Okay. So these are few problems I want everybody to work upon. All right. See you next week, and hope to see more action. And in case you are stuck at any point of time, in case you feel left out at any point of time, please reach out to me. Okay, reach out to my team, put it in the group, and yes, at any point of time, you should never feel that just because you did not attend the previous class, you are not able to understand it. Okay. Even if you missed all the classes so far, I would try my best to bring everybody on the same page. Okay. So feel free to reach out at any point. Okay. Those who feel that they are left out, I would probably schedule separate session. I'll ask my team to schedule a separate session during the week so that those who think that they are left out, they should be able to catch up. Okay. So yeah.
Thank you.
All right. Let me just share the notebook right away. Yeah. Okay. Can somebody put it in the WhatsApp group as well? Okay. Yeah. Perfect. I look forward to see you next week. And yeah. Those who are comfortable with programming, they should try the recursion problems. And those who are not comfortable with programming, who are beginners, they should try these problems.
One query I have, like with recursion, what kind of problems we can't solve?
You can't solve the problem.
Means what kind of problems we can't solve, like how to detect that pattern.
Yeah. So if you can reduce a problem from n to n-1, then you can solve it using recursion. If you can't reduce the problem, then you can't solve it. Okay, as simple as that. So recursion, like for example, in case of Sudoku, right? Or let's say you are putting, let's say you are solving Rubik's Cube. Okay, so I can take a simpler example. Okay, let's say you have to basically, given a string, you have to print all permutations of that string, right? N number of characters you have, and you want to do that. Now, if you are given the solution for n-1 strings, can you use that solution for one more letter? You can, right? Let's say you know the permutations by AB. AB, BA. So what permutations can you generate? You can put C in between and C at every point, and that will be a new permutation, right? So you are able to reduce if you are given the solution to n-1, you can solve for n, okay? Or you can say, if you know the solution for n, can you do it for n+1? That means that that it can be solved with recursion. Okay. So I think work with me. Those problems that we have talked about, factorial and everything, try solving at your own end, like multiplication, factorial, and just try solving them. And you will be, I think you will, when you yourself explain to me, it'll be better. Okay. So, I mean, it's very hard to explain. It's actually easier to do. Okay. Yeah, I tried explaining like what's a function to my son long back. He was asking like what's a function. Okay. Then he gave me an explanation after he understood that function is like a gun. You load it once, you can use it as many times as possible. So define it once and then you can. So I did not have to teach him. I tried explaining, but it did not work out. Okay. So yeah, but that's the thing. So I think as you do, you'll figure out. Okay. As you do, you'll figure out. Okay. The more problems you are solving, the more you will be able to see. And I think it's better to also see everyone's solution. So those who are solving the problem, it's okay to share on the WhatsApp group. And those who are struggling with it, they can also take a look at the solutions. Okay. So it's completely okay. So, I mean, the thumb rule of writing good code is read good code and solve lots of problems. Okay. And that's a thing. Okay. I have read so many times, so many different kind of code. So I'm able to quickly. Yeah. A question from Subodh. The next topics. So this is my plan. Okay. Next week, I'm going to go with loops, and I'm going to basically, after the loops, rest of it, I'll mostly mix it with the algorithm data structures. Okay. Because after the loops, everybody would be more and more comfortable with things. I have already talked about lists and dictionaries briefly, but I'll essentially, from here, basically, we'll start solving more and more problems. So next week, we'll start with loops and iterations, and then we will start with problems. Okay.
Yeah. Why I was asking is based on the Excel sheet or list of topics which was sent, right? Or which is attached to the email. We at least that list says that we will start looking at the prerequisite for machine learning, everything from next weekend onwards. I believe that we'll need at least few more classes to cover data structures and rest of Python. So I just wanted to understand how much more of coding and DS we're gonna take before we start.
Okay.
Uh,
Let me be honest. Let me be
Hmm.
honest. I will take at least 2 more months. Okay.
Okay. So
Yes.
we are looking at somewhere around August to start with the basics of machine learning.
Yes. Yes. And
Okay.
you wouldn't actually know that by the time you start that course, you would have understood everything. Okay. And that's my aim. Okay. So by the way of coding things, by the way of solving these problems, you will learn how to design and write the algorithms. Okay. And when you look at the course, you will say, oh, this is all obvious to me. Okay. And yeah, so this might look awkward, but that's the thing that I'm aiming for. The 2 months, I'm going to work on solving data structure, algorithm, maths problems, and the coding problems. And if you can, work these 2 months really hard with me, all of you, this is for everyone, you'll be different people. Okay. And it'll be different people, I guarantee that part. Okay. Because some of the things I just want to give you a heads up. One of the things that I want to will be like as soon as we are okay with algorithms and so on, in the middle of it, we will be okay working on this particular notebook where we would be essentially coding the linear regression and backpropagation as part of the coding assignments. Okay. As part of the coding assignments, we'll be, what's happening here? It was working fine. Okay. As part of the coding assignments, we will be basically breaking down most of the algorithms into problem coding exercises, and we'll be solving those. Okay. And this bugged. Are you guys able to access it? Okay, let me just put it on the chat. Okay, so yeah, so you can take a look at it. I'm hoping that it should be able to handle. Okay, so we will be looking at this notebook, and yeah, so as part of the coding assignments, like I have already started with slowly with the distance formula, the absolute distance formula. These are used in machine learning day in, day out. And once you are comfortable with these terminologies, once you're comfortable with how to code it, then you will be able to feel when you look at the regression problem, they all would look tiny to you. Okay. So you will actually say that, okay, we actually don't need to spend too much time on machine learning. We should spend more time on this. Okay. And I aim to do that. I hope everybody is okay with that. Okay. And though that was not the plan when I launched the course, this plan had changed after talking to quite a few people in last few months. Okay. Because the course was long, like plan of the course was approved around 7 months ago, 6, 7 months ago. And the plan, my plan changed in last 3 months when I looked at many people in the industry, when I taught the other class, other batch. So my plan changed, and I'm going to include maths, data structure algorithms, machine learning into the coding exercising while we are learning Python. Okay, so most of the things are going to be that way. And yeah, so my request is, if you guys, any of you are stuck at any point of time, feel free to speak out, right? And this is the good time. If you want me to slow down, do let me. Okay, at any point.
So, Sandeep, I mean, yeah, DS and algo is, sort of base of everything. But then will we be able to cover up all the topics which are listed, because I don't know. There are many topics which I know about. There are many topics which I don't know about. So I didn't know how much we can put in. For example, building training models, classification, and all that, right? Ideally, all those should have been touched by August. If you're gonna push that, will we able to cover all those, or you have that?
Don't worry. Don't worry. I'm like very expert at this. Don't worry. Okay. My biggest fear is this. Okay. My biggest problem is this. I can finish everything on time, but nobody will learn anything, and everybody will believe that it's their mistake that they did not learn. And right. And you won't even blame me. And that's the thing. So I will handle that part. Don't worry. That's a thing that you will learn. And the reason I'm doing this in an inverted way is that if you black out now, like if you do not learn the coding and everything now, everything will look like a separate topic to you. Like the entire machine learning, deep learning, everything will look like a separate topic to you. But if you finish now, the way I'm going, all of the things will look like obvious to you. I don't need to
Yeah.
teach you.
Yeah,
That's a
Sandeep, this is one thing I also want to mention coming from a previous batch. Like initially, these things look awkward, like where we are heading, you feel like you're losing the momentum. But once you pick the pace and when you feel comfortable around coding and all, the topics around machine learning and AI will be a lot more obvious and easy to
yes,
grab. So
yes,
initially, it looks tough and time
yes,
consuming to absorb these little topics. But once you gain the momentum, things will be a lot easier for you. So it would be like, I would say, what I have noticed in this course is you require a constant learning, but you don't have to overburden yourself. Spending like 2.5 hours each day is more than enough in this course. But yeah, consistency is one thing that we should all be seeking in. And if we want to get hold of, uh, you know, um, want to get hold of, you know, techs like ML, DS, and
yeah,
AIs and what.
yeah, yeah. So yeah, so don't worry. You are in safe hands. And my promise is not about finishing the course. My promise is helping you guys build a career, helping you guys change the career. My promise is that, and that's what I work on. It's not like that's what I aim for. And it's my promise is not about, okay, I finished the course. Okay. And because I mean, the only reason why people sign up for my course is essentially that they have been like their friends have referred them and they have been successful. And yeah, so I think don't worry. I mean, that is something that you leave it to me. Okay. So I know that this is a
All right.
this is a common question that many people would ask me, and even like many people would ask me, like my entire team would ask me. But yeah, so my actual focus when I actually many of my classmates went for their masters in the US. Okay, and they asked me that, can you take our interview on machine learning? Can you do a mock interview for us? And when I asked them questions, it became it became very awkward that they could not solve a simple question. And it's like very weird. And such a simple questions like I was interviewing the candidate from NVIDIA, and he's a research scientist, Flipkart's research scientist. And to me, the weird part was that they could not code up a basic thing for me. And that's something very alarming. And when I looked at all my friends and all these people who have been interviewed recently, even though they are done their masters and they have done spent a lot of time learning machine learning, so the problem is that they are not able to code up things, and because of it they can't clear the interviews of Googles and Facebooks. Okay. But my aim is, because in machine learning interviews, right, the kind of questions people would ask you is not the machine learning question. They'll ask you questions on coding. The first round is going to be coding. Second round is going to be maths. Okay. And there'll be questions related to both of the things together. And machine learning is just one part of it. Okay. And like I'll tell you, one of the interview questions at Google was like, how would you make the model smaller? And the question till that point of time in 2014, the tiny ML the quantization paper was not published. So it was obvious to me. So I was able to code it up and say that this is how it's done. Okay. So yeah, coming back to it. So work with me. Got it. You are on unmute.
नहीं करो मैं
Yeah. Okay. So yeah, don't worry. I mean, I think work with me on these problems. I know the direction. Where are we going? And we will basically, yeah.
Sandeep, all these assignments we have to send it to Cloud that reaches.
Yeah.
There,
Just
right?
keep. Yeah. Just keep it ready. Okay.
Why did
Just
you share that as assignments in the chat
Uh,
itself?
I sent a notebook to everyone. Okay. All right. Yeah. So yeah. All right. All right. Everyone, please feel free to reach out and have a good week ahead with this. And yeah, help me understand if I am fast or slow. Okay. So help me understand the magnitude. My direction is correct. My direction is towards where I know the direction is correct. If you are able to grasp and go on, or is it like I'm going too fast or I'm going too slow, please let me know. That would help me a lot. Okay. Direction, leave it to me. I'm going in the right direction. Okay. The magnitude is that I'm worried about. Okay. So feel
Hi,
free to.
Sandeep. Yeah, great session. Thanks a lot for clarifying the doubts. Just a small request. When we are covering ML, I have not seen if it is part of curriculum or not. Are we going to also cover how to test the accuracy of the model?
Those things are part of the problem.
Okay,
Yeah.
cool. Thank you.
Like, for example, mean squared distance that I'm giving you, it is used to compute the accuracy. That's one of the measures. Okay.
And also,
So, yeah.
if I say the statement, the accuracy or the maturity of a model depends on the enriched data set that we gather, right? Or a period of time it is trained over. Are there any shortcuts to do that? If such tips are also there, or if you come across any resource, am I
You
being
will
too
learn.
greedy? I don't know.
You
Yeah,
will
please.
learn. You will learn in a more gradual fashion. Don't worry.
Okay, thanks a lot.
You will learn in a because see the challenge is I don't want any of you to memorize anything.
Yeah,
Okay.
Actually,
And
I am layman to machine learning, but when I
yeah.
have heard in Scrum calls and all in other conversations, when we come across a situation where someone does a model in a very it's very minimal AI, it's not utilizing all AI capabilities. A backend person comes and says, I can write this in Java service and it will be more efficient, less time cuts. So I wanted to understand where we can do better when we are learning ML. You understood, right? My point. Yeah.
Understood. So basically, these are key terminologies. And if you have time, there is a right in my courses. If you are in hurry, just take a look at the, let's say, like various terminologies. People use accuracy. People use F1 score. People use something like the truth table. What do you call that? Confusion metrics. Okay. And then people use all these matrices, and so basically that's basically the basic terminology, right? And my agenda in the course is going to be that, of course, terminologies are a standard part, but you should know exactly what's going on. I'm very surprised as I joined, like as a couple of people joined my team, and when I interviewed them, they could tell me all about mean square distance, okay, but they could not write the code to calculate this. The that question that I've given today, okay. So yeah, and basically that's a very, very critical part. So I think you will all learn all about it. The second chapter in the course where we talk about classification. So the way we have I flipped the course a bit. First, we are going to do this prerequisites. We are going to finish these prerequisites. Immediately after the prerequisites, what we have is we will have the end-to-end project. Okay, end-to-end project, meaning you will be able to say take a business problem and solve it right away. Okay, and then we will go into each and every technique, how to, like the linear regression works, how does decision trees work, and all that keeps on going. So we solve 2 to 3 problems, end-to-end project. One is on classification, other is on regression, end-to-end like in industry, and you are all good to go. At that point of time, immediately after those 2 projects, you should start working on at least one Kaggle problem. Pick a problem from Kaggle and start working on it. And while we are studying the machine learning part, like the actual algorithms and models, that you are already ready to go and start appearing for interviews anywhere. So it is like that. Okay. So yeah,
So,
I think.
Sorry, go ahead.
No, I had nothing to say. Yeah, I was ready.
Yeah. So is it possible that you can share the new schedule? The reason why I'm asking is that now, as this is a year-long session, right? There will be some weekend where something is coming up and we want to plan ahead. That tentative timeline or tentative subject which is going to happen, right, will be very helpful. So is it possible to share the newer schedule?
Yeah.
Even if
I'll
it is
try.
tentative, that would help.
Yeah, I'll try. So the thing is that my only request is don't miss a class. Okay.
No, yeah,
okay.
of course, but
Yeah.
that as I said,
Even
right, it's a year-long course.
Yeah.
There can be some genuine issues, right, where we may have to do it. So it will be easier for taking a call, right? So if that makes sense.
Okay.
I'm trying to be more practical. I understand we don't want to miss out anything, but to be more practical, if we have some schedule, it will be pretty helpful.
On all your family holidays, you will be attending the class. I can tell you. And I have done this for last 10 years. I have essentially every weekend I have taught people, and I would say, and I have taken the class from every friend's house so far. Whenever we go for a party somewhere, like after the party, we have the class. Yeah, and this is So for 1 year, you will not be drinking alcohol because we have a class. Okay. Yeah. And
I've changed my days from Friday to Thursday.
Yeah.
For the same reason.
Yes.
No.
Yes.
Yeah.
Yes.
No. I mean, the reason I'm asking is there are certain travels which I'm going to do throughout the year, right? And mostly
You can do it. You can do it. Yeah. So
yeah. So just
that,
if you can share the list,
yeah,
it will
I'll
be
try.
easier.
I'll try.
Awesome.
And yeah. And but again, it's going to be a little difficult for me to prepare, though I'm working on it. But yeah. Okay. So awesome. And yeah, I think let me share that. Let me try working probably on Monday. And yeah, anything else, everyone?
Hey, Sandeep.
Yeah.
Can we cover the data science part also, na? For the we are mentioning the curriculum for this course, like the data mining and the data analysis part. We also cover not only for the restricted only the AI.
Yeah.
At the end, we cover the data part also.
Yeah. So a lot of topics are self-paced, like those people who are trying to learn about data engineering, people who are trying to learn for DevOps. Most of these things are added one or two projects on every topic as a self-paced course. So those who are interested, they can do that. And yeah, and
We can
since
share our doubt here, right? We can ask the problem here or
yeah,
related to the any topic like the AI and data.
yeah. At least in my class, at least I'm not sure. When Professor Raksha will be taking, I'm not sure about that. It'll be up to her. Okay. But for me, right, I'm okay.
So I know we are going off topic and we are way late. Just one quick question. So the D topics, right? Data engineering topic, which you said are mostly self-service or self-study. Those are not in our my courses, right? They
They
are
will be
already
marked as
there.
optional. They will be marked as optional. I'll ask them to add it if it's not there. Is it not there?
I did not see them, at
Yeah, it
least
will
in
be
my
there.
list.
It will be there in the Excel sheet. It's the last of the four.
No, not the Excel sheet. I'm talking about when you go to Cloud Labs and see my courses, right? All these are already there, but DE courses are not there. I didn't see it. So if there are some self-study, right? And if it is there, then it will be easier us to look at them.
Okay, let me check. Okay, because this is a 1-year course that is included.
Yeah.
It is supposed to be part of the
course
self-learning.
not available, right?
Okay, which one is the course number for you?
So the course number, how do I check this?
203, right?
Course number is 203. 203, yep.
Okay. So I'll get those added if it's not there. Probably it'll be added here. Okay. So it'll look a little intimidating, but don't worry, we'll mark most of them as optional. Okay. So that doesn't become a roadblock for the certificate. Okay.
Okay.
Only the Pandas and the Matplot is available. Other thing is PySpark thing is not.
PySpark is not. Okay.
Not available. Yeah.
Yeah,
PySpark.
I'll inform them. Okay. So it's that content is like very crisp and small, and it is going to be it's going to be pretty easy for all of you. Okay. Yes, Omdar.
I have a basic question. Maybe you might have touched upon this earlier. Is that these algorithms, a lot of algorithms are available and they are being developed. Similarly, LLMs are available and being developed. The focus of the course is to develop some algorithms or use them to solve business problems. I mean, it may be esoteric to write those algorithms, it helps in understanding them better and all. Practically, I think more uses with the user algorithms to solve the real world problems. So what is your advice there?
Okay. See, my advice is this. Okay, and this is a question that I get asked very often. Okay, we invented calculators in 1930, but we still learn maths, right? And we invented all these algorithms long back. And still, I believe that you should know how to code most of them. You can only, as a thumb rule in computing, you can only use those libraries where you know the psychology of the algorithm. Okay. Otherwise, it becomes very difficult to handle. Okay. So there are some very esoteric algorithms that we will not be kind of touching upon, but rest of it is actually, I believe that it's just common sense. It's not that difficult. I can guarantee you that part. You wouldn't even realize that, oh, you were able to do it. Okay. So I honestly believe that it's just a common sense because most of us are really, really good at learning things in normal life, right? And we are making a machine to do the same thing. And that machine is probably not having like 0.0001% of accuracy. So I believe that all of us can write those algorithms. In my other classes, everybody has been up and running with those. Okay. So the reason I would say that the reason I want to address the algorithms and I want everybody to code, that the biggest mental block that most of the engineers I have seen in past, they face is that they are very afraid of the term algorithm. They think that, oh, this is done by some scientists. And I had the same problem in the beginning, that when I looked at the recommendation engine, and basically most of the scientists would like to make you believe that, oh, this is to be done by only mathematicians, not by me. But it's not. It's pretty simple. I can assure you that. The reason I want to do it again, let me repeat again, that uh, if I just teach the models, okay, most likely you will just memorize most of the things. Okay. But if I teach you how to build all of this, then I don't need to teach you complex ideas. Complex idea you will figure out by yourself. You will be able to read papers, you'll be able to read through any strategy quickly and then do the things. Okay. So my aim, of course, we will be learning how to utilize all the models, but we'll also learn how these things work internally. Okay. And I can guarantee that if you are not able to understand, it's my mistake. Okay. I'll make my right. So I'll make sure that everybody understands. Was I able to answer your question on that?
Yeah, definitely it helps. I kind of was looking at it when I was coding for this blue score that you had given as assignment. So it was a good understanding, although it took some time.
Yes.
So my concern is not about the fear of algorithms or anything. I have a lot of experience in doing that.
Yeah. See,
My point was about the time that we have to spend where it is best utilized.
It's okay. So we are going to this time is most important time. That's the thing I'm saying. This is the most important time. And I think basically one of the things that I honestly believe, like when I look at kids, when I look at adults, when I look at somebody who, let's say, there was like when we talk about logarithms, we'll talk about logarithms very soon. And there were many people who were thinking that, oh, logarithms are not of use, and we don't want to use it. We just use the library, right? What's the point? Now, the main reason was that somebody who taught them algorithms, or somebody who taught them what is logarithm, did not understand what is logarithm. Okay, and that's why that thing kept on moving. And once you miss out on one idea, then another idea, then another idea, then another idea, then entire thing blacks out. And everything starts looking like a black box very soon. And that's why the basic parts, starting from the basics of maths and the coding and the data structures and the algorithms, that is something that I believe that I want to make sure that everybody's on the same page. It's not a waste of time. It is the purpose of the class. Purpose of the class is that when you look at a problem, you should not have a fear. When you look at the interview, when you are attending the interview, you should not have the problem, right? Many people think that, okay, training the model, the algorithm is actually very hard. No, the algorithm is actually pretty simple. The backpropagation algorithm that every neural network uses is essentially something that will be coding in this course now. Like when we talk about the Python exercises, we'll be coding up that one, and it's pretty simple. And you'll be amazed at that fact. So, I mean, yes, most of the researchers have an selfish interest to portray that this is the thing that is very difficult and people should not touch it. Like if you read the paper, if you read the paper of any OpenAI or anything, the paper will look very complex. If you see like computing average, if you see that formula of computing average, it's like sigma I, or let's take min, finding the minimum of a list of numbers. Okay. There is a big sigma and I, and then there is this terminology. And the moment you look at that formula, you'll freak out that, oh, there's something that I can't understand. So most of the algorithm are actually pretty simple as compared to what is portrayed. Okay. So, and it's just that, just like in a Rubik's Cube, each move is like easy, but when you combine all these moves together, the Rubik's Cube suddenly becomes very complex. Similarly, if each move is not understood properly, everything will start looking really complex to you. And that's why I'm going to spend good time and have that. I would request everybody to have that faith, that little faith that is going to work out. Okay. And yeah.
That helps us clear the direction that we'll be having.
Yeah.
Just one more question which I had, maybe the final question, is that this pace of change in this particular space is very high. Are you open to changing the course content as the things move? Because last
Yeah.
year,
So my previous course and this course are very different. Just the one that is started 3 months ago.
Okay.
Okay.
Thank
So,
you.
I mean, otherwise I'll die of boredom, right? If I'm repeating the same thing, right? Every course has to incorporate everything that's new. And yeah, and that's the thing that I work upon. Okay. And yeah, so don't worry about it. And the interesting part is that most of the things that we are using, even to build ChatGPT, were invented long ago. Almost every part. Okay. So, and the fundamentals are still the same. All right. Perfect. Wonderful. And yeah. Perfect. I hope I was of, you can justify your couple of hours lost in life. Okay. All right. So have a good week ahead and reach out
Thank
in
you.
case.
Thank you so much.
Thank you, sir.
Thank you, Sanjay.
Bye.
Thanks, Sanjay.